So these are directions to help you with the Hess's Law Lab. In the Hess's Law Lab, you are going to do 3 reactions. And in these reactions, you will find the change in temperature. And what the change in temperature is, actually all of these will get warmer, so they're exothermic. What the change in temperature is the temperature will go up, and it's directly related to the heat or the enthalpy change. And you can use this in the calculations. So this is the calculation you're going to use to find the heat that's evolved. And the thing about this is the temperature goes up because the molecules are moving faster, which means the kinetic energy went up. And if the kinetic energy went up, it means the potential energy went down. So you're going to use that calculation. And from this calculation, you can find the enthalpy change. And the enthalpy change will be Q over the number of moles. And the number of moles we want to use is from the limiting reactant. And if you do this correctly, the limiting reactant in all 3 of these should be KOH. So you'll use the moles of KOH in this calculation. The specific heat you're going to use for water. Although I realize this isn't pure water, it's almost pure water, so we're just going to go ahead and use the specific heat of water in this calculation. And the mass, don't get this confused, the mass you're going to use is the mass of the solution. It is not going to be the mass of the KOH. The mass of the moles of the KOH will be here. So this is the Q that you will use here. So that is generally what you're going to do. So I'm going to go over some of the specific directions. Oh, and then what you'll find is when you calculate the heat of reaction using Hess's law, if you add 2 of these together, you should get the heat of reaction for the 3rd one. So that's what the Hess's law is. Add 2 of them together, and it should be the heat of reaction for the 3rd one. So there's 3 reactions. And what I suggest on the first one is get the mass of the cup. And you have a small beaker, get the mass of the KOH. And the first one is water. No, excuse me. The first one's water. So you're going to have KOH in here. And by the way, the KOH is solid, and you don't really want to touch it. It's a base, and because you get on your hands, you should rinse your hands, but it'll be kind of slimy. A base, you can't get the last layer off. It's real important today to use your goggles and not touch your eyes. Because if you have base, even if you try to wash it off, it's not going to all come off, and so if you touch your eyes, you don't want to do that. So you have the mass of this. You get some KOH in here. You put some water in here. Put the thermometer in. And you're going to have to get a magnetic, it looks like a hot plate, but don't turn on the heat, just turn on the stir. There's a magnetic stir bar. I do suggest when you're getting the mass, you probably want to put the stir bar in there and get the mass with the stir bar. Because then you're going to add water, you're going to put the thermometer in, start the temperature, and then add the KOH. And the temperature will go up on reaction 1. And then the temperature should go up and kind of level off, and then it'll start to go down. So you want the level, the part that's level. So you have initial temperature and a final, and then you'll get the mass of this. So you have the mass of the cup and the magnetic stir bar, then you'll have the mass of the cup, the magnetic stir bar, and the solution. And so what you want is to subtract, and you want the mass of the solution, because that's what you're going to use in this. This is the mass of the solution. That's what you're going to use in here, is the mass of the solution. Now, then you're going to take that and you're going to put it over moles to get your delta H. And you're going to use the moles of the limiting reactant, and the moles of the limiting reactant should be the KOH. So that's why you wanted the mass of the KOH. After the reaction, you're supposed to check the pOH. It should be acidic because the acid is supposed to be the excess. So if it's acidic, that means that the KOH is the limiting, which is what we want in all of these reactions. That's why you're supposed to test the pH. So then on reaction 2, get another cup, get the mass, your stir bar. Oh, by the way, you want to keep the reaction from 1. And where's my 1? You can get the stir bar out, right? Rinse this off. So you want your stir bar. So you're going to get the mass of the second cup with the stir bar. And this one is going to be HCl. So here's 1.5 molar HCl. So you put the HCl in. Don't forget to get the mass of the cup, the dry cup, and the stir bar. Start the temperature probe, and then you're going to add solid KOH. The temperature will go up, level off. You then get the mass of the solution. So you get the mass of the whole thing, subtract the mass of the cup and the stir bar. So you have the mass of the solution. And again, you're using solid KOH. Check the pH. It should be acidic, so this is your limiting reactant. Reaction number 3, you're using 2 liquids. So you're going to have 150 milliliters. Don't forget your stir bar. Forgot my stir bar. If you want to get the mass of the stir bar alone, you can do it that way. So get the mass of your third dry cup, the stir bar. You're going to add HCl. Remember, I told you to save the KOH solution from reaction 1. It's about 90 milliliters. So you have HCl in here. Start the temperature. Add the KOH from reaction 1. Temperature should go up, flat line, and then get the mass of the solution. Okay? Are there any questions?